Okay, Assalamualaikum
Okay,
and
dah.
hello to our lecturer, Dr. Rukayah. We are from Group 6 and we will presenting to you our precast concrete assessment. Okay, what is pre-stressed concrete? Pre-stressed concrete is a form of concrete used in construction. It is substantially stressed during production in a manner that strengthens it against tensile forces which will exist when in service. Pre-stressing is the intentional creation of permanent stress in a structure or assembly for improving its behavior and strength under various service conditions. Belum lagi tadi. Okay. In prestressed concrete, compression is induced prior to loading in the zones where external loads would normally cause tensile stresses. Okay, next slide. Principle of prestressed concrete. Large prestressing force are applied to the member by the tendons. High band stresses are developed at the ends and anchoring services. By the anchoring devices. The anchorage are generally designed to be meant for use only for high-strength concrete work. Busting stresses liable to at the ends of the beam cannot be satisfactorily resisted by low-strength concrete work. When stress transfer to concrete has to take place by bond action, the concrete should have a high-strength concrete. Shrinkage cracks will be very little when high-strength concrete is used, due to the high modulus of elasticity of high-strength concrete. The elastic and creep strength are very small, resulting in smaller loss of pre-stress in all steel reinforcement. Okay, next slide. Okay, play the video. Okay, in case of big concrete construction project like bridges, steel reinforcement bars alone won't be sufficient to provide the necessary tensile strength. In this case, prestressed concrete is being used. In prestressing, the rods or tendons are stretched along the axis and concrete is poured later when the tendons are released. The compression is generated at the bottom, which tries to counterbalance the compression due to the loading at the top of the beam. The principle behind pre-stressed concrete is that compressive stresses induced by the high-strength steel tendons in a concrete member before loads are applied. This will balance the stresses imposed in the member during the service. Pre-tension concrete is those in which the tendons were tensioned before pouring of concrete. The tendons are initially tensioned and anchored at both ends. Then concrete is poured over it and cured. When the concrete attains desired strength, the tendons are released and projections are cut out. The pre-stress imparts to being through bond action. In post-tension concrete, The tendons, the tendons are tensions after the concrete is poured. Initially, the concrete is cast around the sheeting. The ducts are formed in concrete in which tendons are placed. After the concrete is hardened, the tendons were pulled by hydraulic jacks and anchored. In case of bonded type, the duct is grouted with sufficient slurry. In the unbounded type of tendons, grouting is not necessary. Okay, sudah siap saya punya.
Hi, now I will explain about the method of prestressing. There are two methods of applying prestress to concrete, which is pre-tensioning and post-tensioning. So for pre-tension method, tension method is those in which the tendon are tensioned before casting concrete. Usually, this method is used to manufacture a large number of similar precast concrete, and this method is a factory-based operation. And for post-tensioning is when the tension is applied after the concrete is hardened based on required strength. This method is an on-site operation. Usually be used when the structure involving large and heavy span such as bridge. Okay. Next. Here are the procedure for pre-tension concrete. First, we start with bed preparation, then placement of wire or tendon, anchoring, then we apply stress by use and casting of concrete, lastly cutting. Here are the further details about the procedure stated before. First, we start with bed preparation. Bed is used to casting the concrete. Next, the placement of wire or tendon. A high strength of tendon is used to induce the tension applied. Then, both ends of the tendon is being anchored to induce the tension that need to be applied. After that, stress is applied to the steel tendon by use of hydraulic jack. Before next, concrete casting. Concrete being poured and left. Finally, after the concrete hardened and reached desired strength, the tendon is released by cutting. Next. Here is a video for pre-tension concrete. Tak ada bunyi. We start with bed preparing to casting the concrete. Next, with placement of wire or tendon. Anchoring at both ends to apply stress. This is the jack that used to apply this tension to the steel to the tendons. And casting of concrete. Plus cutting after require enough strength. So that's all for pre-tensioning method. We'll be proceed with post-tensioning.
Okay. Can I show to the next slide first? Okay. 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 So basically, I will continue for the post-tension procedure, which is almost the same from the pre-tension, but basically it just stress the tendon after the concrete is hardened. So the procedure started as start with install the formwork and lower reinforcement. Then determine the position to locate the tendon, which is identified in the design stage. Then install the anchorage and ground vent. The ground vent is optional, either it want to be the bonded or unbonded. So next is placing the top reinforcement, and then pour the concrete and wait till it harden. After it harden, the block and joist been insert, which is you can see after this at the video, and also apply the tension based on the design by using jack. When the tension is applied, we can measure the elongation of the tendon, and also cut and cover the socket and grounding the void. Grounding the void is usually for bonded. So we can see the example from the video. So this video is more detailed process for the post tension by SNP company. Okay. So basically, most of the example that I found, usually the post tension used for making a pre-stressed slab. So this is the installation of the formwork and lower reinforcement of slab, which is installing the anti-bursting. This is for slab procedure. The lower reinforcement in column. Determining the position and placing of the bar chair for locate the the placing tender and tight the bar chair. Okay. This is the story of anchorage and ground vent. Then the top reinforcement. And pour the concrete. Wait until it harden, then remove the sign formwork. And this is a former. This is a block and joist for the tendon. The spray is to measure the elongation after it been stressing. The difference between before and after. Cut the strand end and fill the socket with mortar. So this is the process for the grouting. First, we will bleeding air for cleaning. We pump the air into the socket, into the something like that. Then the grounding process for bonded. Then we repeat for the same step for another level of the slab for this example. Thank you. Okay, that's all for me. Thank you.
Okay, hello. My name is Daniel. Now I will explain my part, which precast concrete versus in situ construction method. We will discuss with fact lah. Right, next. Okay. The question is, why precast concrete is preferred compared to conventional in situ construction method? Maybe some say that precast concrete is a lower total cost, lower lifetime cost, use less cement, water, say, and labor. And some conventional in situ construction method say that produce more waste on the site. Majority method will be used for construction, but makes carbon dioxide footprint bigger. So which is better? Okay. Next. Okay. For the just an introduction for the little bit, precast concrete is a construction product produced by casting concrete in a reusable mold or form, which is then cured in a controlled environment, transported to the construction site, and lifted into place. And in situ conventional construction method, in contrast, standard concrete is poured into a site-specific forms and cured on site. Precast stone is distinguished from precast concrete using a fine aggregate in the mixture, so the final product approach the appearance of naturally occurring rock or stone. Right? Yes. Now, I take according to the other researcher, why they say that precast concrete is better than in situ in conventional construction method. Vic Karthikeyan say that in the study on comparison between prefabricated and conventional structure, suggested that through light on how their new methods are evolving in selection of material and construction. This new method can improve productivity and quality of work. It helps provide organized body for determining cost of construction. Right? Next. And other researchers say that Reza, in study using prefabrication system in building construction, he said that interprets that prefabrication system might have some potential of increased use in future because of their characteristic. This paper clearly deals with the standardization and customization involves in prefabrication. Standardization and customization play such as important role in prefabrication construction process. Okay, next. Okay, for the conclusion, we found that I found from the other researchers, from article, from website. So I conclude that precast concrete is more cheaper than in situ construction because there is no formwork to be erected and stripped. So low cost for the precast than in situ. Okay, and then precast concrete give a shorter total construction time, and then precast concrete is faster because element are assembled on site without any waiting period for concrete to cure. Right? And then lastly, precast concrete give a better quality than in situ concrete. So these facts I found that from the Lugu, at least in 1996, in study in situ versus precast concrete construction, a comparative investigation of the effectiveness of on housing development project. So that's why precast concrete is better than in situ conventional construction. So thank you for listening. I wish it helps for the understanding why precast concrete is better than in situ construction method. That's all. Thank you.
Okay, next, I'm gonna talk about benefits of precast toward the environment. First of all, precast concrete component can be reused because they are formed with high strength. Precast concrete component is included formwork, like Daniel said before. Conventional method will use many type of material such as timber formwork, if we use precast, we don't need to use that material anymore. So automatically we can save many trees and reduce the amount of carbon dioxide. Okay, next, precast concrete can be transported easily in lesser number of trips. Precast concrete, as we know, they been made in factory, and then after we finish the process of making precast concrete, we transport to the exact location of site, and then we can reduce the amount of machinery working in one time. So we can reduce the amount of carbon monoxide and reduce the global warming as well. And then lastly, precast concrete method can reduce the construction time at the construction. If the construction time can be reduced, the usage of machineries and manpowers will be reduced as well. If we use the traditional method, conventional method, manpower and machineries will work at the same time. So many carbon dioxide, many pollution will be happen. So if we use precast concrete, we can reduce that rapidly. Okay, that's all. Thank you.